Okay, and for one final twist in part D, the question moves into a binomial context. And it's good to think about the kind of clues we've got. We know we have a binomial event because you can either succeed or fail. It's one or the other. And we're also told there will be 10 events. And these are generally good clues that you're in a binomial context. There's lots of events. There's no way you can necessarily do it via a tree diagram. You're never going to be able to draw it. So we also know the probability of succeeding is 0.8143 cubed. We did get that from the previous question. It's the idea that to score a point, all three of the darts had to be in this particular area. So that means I have this probability cubed. So that's from the last part. So we know the probability of succeeding. And then we're asked, if I play this game 10 times and this is the probability of succeeding, what is the probability that I will win at least 5 times? Okay, so here we have a binomial distribution with the number of trials being 10 and the probability of success being this number here. And I've left it as 0.8143 cubed so I don't have to worry about rounding. And I want to know what's the probability of at least 5 wins. So I know I'm looking at a cumulative distribution, a BCD here, because I'm looking for 5 wins, 6 wins, 7, 8, 9, 10. They all count as far as I'm concerned. So the lower limit is 5, the upper limit is 10, and the number of trials is 10, and the probability of succeeding is 0.8143 cubed. So I can now calculate using my binomial cumulative distribution on the GDC that the probability of at least 5 wins is 0.717. Now, for part 2, it's very, very similar. It's exactly the same distribution, but there's an added condition. We want to know the probability of at least 5 wins, but definitely less than 8 wins. And this is something to watch out for. Just be a little bit careful, because this means that the upper limit will be 7. I can't have 7.5 wins, so it's either 7 wins or 8 wins, and it clearly says less than 8. So it's quite tempting just to put the 5 and the 8 in there, but a little bit of thought and attention to our greater than or equal signs will help us recognize that the upper limit is 7, and that's the only difference. And so I do that and I get a probability of 0.628. And then the last question asks us for the probability of this, having at least 5 but less than 8, given that we know there were at least 5. And the given that command term is really important to be familiar with. It means if we do a simple probability calculation where we have what suits us out of all the possibilities there were, the given command tells us to change the bottom number, the denominator. So this is now the probability of there being at least 5 wins. So it's given that I'm definitely in this territory. What's the probability that I'm in this territory? Well, it's quite simply the answer to part 2 divided by the answer to part 1. The probability of at least 5 but less than 8 out of the probability of at least 5. So we can use our answers to the previous question and calculate that we get 0.876. Now do be careful here. I've used my rounded answers and that would be okay. As much as you can avoid using rounded answers, that's usually a good tactic as well. I avoided it here by using 0.8143 cubed, for example. And that's the answer to part 3.